Mr. Chairman, fellow engineers, scientists, and others, a warm welcome from the Knysna Forest. Marvin, it's an honor to be part of the INMR Conference, and let's, without any further ado, get going with the presentation on a power utilities perspective on outdoor insulator selection for polluted environments, with emphasis on using the latest IEC specification 60815. The old technical recommendation served us as utilities well. However, with the new technologies becoming available, hydrophobicity transfer materials, RTV coatings, new profiles, new manufacturing techniques, and so on. And also with the methodology of doing site pollution severities and so on. A lot of work has been done in CGRE and a lot of work has been done by ISC to end up with these four documents, which is the new 60815. And in one sets the scene. 2 is for ceramics, and 3 is basically for hydrophobicity transfer materials, or the new composite materials, and that's for AC. Unfortunately, we will not be covering the document for DC, and at the same time we won't be taking aging and failure modes into consideration, as this is not covered in the new ISC 60815. Now, what's the big difference? Site pollution severity measurements is very important in the new 815. Also, non-soluble deposit density, which is the insoluble component of the pollution, is taken into consideration. Use of natural and artificial pollution tests is deemed very important to help with dimensioning. It's recognized that creepage distance or creepage length is not the only parameter to look at. And at the same time, type A and type B pollution, where type A is a pre-deposit with a critical wetting and type B is an instantaneous pollution event. Then 3 approaches have been identified for dimensioning, and the introduction of unified specific creepage distance. And obviously the polymer side is included with hydrophobicity transfer materials. And there's the 4th document, which is for DC insulators. Best is to take a practical example to compare the old with the new. Let's take a 132 kV substation and interconnecting lines to be built at Koeberg Nuclear Power Station along our South African west coast. It's 600 meters from the coastal high water mark, and strong coastal winds and low rainfall with a regular salt fog events, Malmoki mist. And we will be needing a substation insulators. We're going to need posts and hollow cores and long rod strings and so on. And at the same time, in the lines, we're going to need long rods or strings. And there is a maximum connecting length of 1.48 and a minimum insulation length of 1.2 meters and a minimum dry arcing distance of 1.5 meters. We would like open aerodynamic alternating sheds, S over P ratio of greater than 1, and hydrophobicity transfer capabilities. And then obviously we would like to include the new statistical methods as required by the approach 2 of the new 815. 5, we would have determined that the area is very heavy. We would then take the very heavy and classify it as we need 31 millimeters per kV, and for the hollow cores we need a 10% higher creepage distance. Profile-wise, Eskom would have, we specified open aerodynamic alternating shed profiles, and the S over P ratio from our field experience we specify as being 1 and larger. And at the end of the day, the focus of the old 815 was simplicity and ease of use. For that same area, we would have said either greasing or washing, but we know that doesn't work from our practical experience. So we would we specify a hydrophobicity transfer material. The three new approaches of 60815. Well, approach one is to use past experience. And so you would go and take a look at existing field or test station experience for the site or the similar site and use that to do your insulator selection with. In approach two, you would go and measure this or estimate, but we really recommend measure the site pollution severity level. Go and select candidate insulators. And then what you would do is you will go and specify test criteria and test them in a laboratory and then verify whether your selection was okay or not. And if it wasn't, you would do some adjustments. In approach three, hopefully you can measure. If you can measure, you would get a better result than using the old 815. But if you can measure, and you can then design, you can come up with a result which is somewhat better than the old 815, but similar. In the words of Lord Kelvin, to measure is to know. If you cannot measure it, you cannot improve it. Measure. In approach one, we've got a weather station which is around about 250 meters from an existing substation called Danafontein Substation. And they've basically given us the following data where the temperatures is between 14 and 20 degrees Celsius with a maximum of 36. We've got exposed strong coastal winds with gusts up to 35 meters per second. And we've got a low rainfall area of around about 320 millimeters per year, and summer is very dry. So high humidity levels nightly and early morning with regular salt fogs. We've got around about 40 salt fog events per year. The 132 kV substation is within a kilometer from the new proposed site. And we've got some very good field experience there where we have porcelain, RTV coated porcelain up there with a specific creepage distance of 32 millimeters per kV. And they've been running well for 18 years. Prior to that, we had bare porcelain where we did some washing and greasing, and we had flashovers annually. At the same site, we've been monitoring the pollution levels for more than 20 years. And from there, we basically could determine the pre-deposit type A pollution as following, and we can see it here on our graph. And it basically classifies it as heavy. However, the same area is also subjected to instantaneous events, and we could reverse calculate from an event that took place on a 132 kV breaker support insulator that was bare porcelain. We could reverse engineer it, and we could classify the instantaneous event as being very heavy. Fortunate to have Koeberg Insulator Pollution Test Station quite close to the new site where we want to build the 132 kV sub and interconnecting lines. On the post side, bare porcelain at 38 millimeters per kV will flash over more than 3 times per year at Kipps. When you coat that same porcelain post, 24 millimeters per kV, no problem. Our experience on our transformer bushing at 30 millimeters per kV, 15 years, excellent. With open aerodynamic alternating shed profiles with the S over P ratio of larger than 1, hydrophobic materials with good hydrophobicity transfer capabilities, works excellent at Koeberg. On the holoco side, the ones we've tested at 28 millimeters per kV, no flashovers. On the long rods, tested at 22 millimeters per kV, no flashovers. However, we do need corona rings at 132 kV. On the string side, the standard glass cap and pin discs at 27 millimeters per kV will flash over more than 3 times per year. However, when you put a RTV coating on it, we have no flashovers. On the fog type side, 37 millimeters per kV, no flashover per year. With the RTV coating, even better. But we could be expecting poor natural washing and cleaning. And we do have a lot of pin erosion issues. Got the data for approach 1. Let's look at approach 2, where we measure and test. Now, we've already done the pollution severity assessment in approach 1, and we've got all the data from Danafontein substation and from KIPS and from the weather station. So now let's go and select candidate insulators. So we've selected porcelain posts, and we've then coated this porcelain post with 2 manufacturers coating. We've got a hollow core insulator which we want to evaluate, and 2 silicone rubber long rod insulators from 2 suppliers. And then we could only fit a string of 10 glass discs into that connecting length. And so we can have a standard one, and we can have one with a coating on it. We sent this lot off to a laboratory, and we specified our salt deposit densities, and we also specified our non-soluble deposit densities, and we had them done for the ceramic ones in accordance to this procedure, and we had it done for the polymeric ones in accordance to that procedure, and we ended up with these pollution performance curves for the various products that have been evaluated. We took this data, and then in accordance to the statistical approach of Annex G in 60815 Part 1, we now wanted to optimize the selection and take into account that we really want 50 years of mean time between flashover. So we used a commercially available package, the insulator selection tool, and put the data in there, and what we ended up with is this type of curves for each one of the products that were tested. And we basically then went and did the calculation, and if we wanted a mean time between flashovers of 50 years for the type A pollution on the long rod A insulator, we're going to be needing 20.2 millimeters per kV. Then if we're looking at the type B instantaneous conductive fog pollution events, then for 50 mean time between flashovers of 50 years, we're going to be needing 22 millimeters per kV. And this we did for all the candidate insulators. Here we've summarized the findings. And if we, for instance, were using 189 porcelain posts at 37.1 millimeters per kV, that is what we can fit into a connecting length of 1.48 with an insulation length of 1.2. For type A pollution at that creepage, we could be looking at a mean time between flashovers of every 10 years, and for type B, instantaneous events every 3.8 years. We need at least 38 millimeters per kV, 39 millimeters per kV for 50 years. For type A, and for type B, we need 42. See, this is not a good option. We cannot fit that into the available space. When we coat that same porcelain post, then you can see we can come down to 28 millimeters per kV, and we can have it operating successfully. On the hollow cores, we can use 28 millimeters per kV. For the long rod insulators, we can use 22 millimeters per kV. For the glass discs, we are not going to make it, because with the 10 disc string, we're sitting with a scenario that they will flash over annually quite a few times, and we need at least 28 millimeters per kV. However, if we coat that glass disc string, we can come away and be in the same order class as what we would be using for the long rods, and that is about 20 millimeters per kV. The same is for the line insulation. Done approach 2, we're now at approach 3, where we measure and design. Fortunately, we do have measurements, and making use of that measurements and with the recommendations in part 2 and part 3 of 815, we end up with very similar type of results as what we got with the old 60815 from a creepage perspective. However, the recommendations on the profiling and so on is slightly different. Here's a summary and a comparison of the results obtained. Let's take, for instance, hollow cores at 28 millimeters per kV from past experience. When we do the measuring and testing, 28 millimeters per kV. Cool. If we had to make use of measure and design of approach 3, we would have gone for 34 millimeters per kV at least. And at the same time, if we used the old 60815, it would have been 34 millimeters per kV. Let's take a look at the long rods, silicon rubber long rods. Interesting. 22 millimeters per kV. That's from our experience at KIPS. And 22 millimeters per kV when we do the measure and test of approach 2. Excellent. So they compare very well. Now, if we go and take a look, if we had to make use of approach 3, we would have said at least 31 millimeters per kV, and we would have said for the old 60815 at least 31 millimeters per kV. And so at the end of the day, we take a look at approach 3, we can see that it's very similar to the old 60815, but approach 1 and 2, we can really start looking at optimizing our insulator selection. To conclude today's presentation, I'd like to give some recommendations to fellow power utilities. Now, firstly, we pay quite a bit for environmental impact study. It's a costly endeavor. And normally they tell us what we and our effect is going to be on the environment, and rightfully we take note. However, they don't tell us what the environment's going to do to our network or our system. So I would strongly recommend that we include site pollution severity measurements within this environmental impact studies. Further, let them tell us what the environment is going to do to our network. For instance, is there birds, or are we going to expect some weird animal or ant or something that's going to chomp up our insulators or whatever? So let's include that into our environmental impact studies. Then, folks, specifying creepage distance. I think really today, with the new 60815 and the introduction of unified specific creepage distance, I think so as to avoid confusion with the old specific creepage distance, specify your creepage distance in millimeters or in inches. Make certain that you give a physical value which is definitely not going to confuse things, because the specific creepage distance does not change in the unified specific creepage distance or specific creepage distance. It's the same. So that is an excellent way to avoid confusion. I've had the situation where guys was totally under insulating a substation in a very heavy environment because they got the two values confused, and that square root of 3 caused quite a costly change that had to be taking place in that situation. Now, further, from our experience, we actually have our outdoor test station kits where we do both the aging and pollution performance, and where we also can get our data from. And then at the same time, having laboratories available where tests can be done. By combining approach 1 and 2, it will definitely give excellent results, especially when you're sitting in a situation where you would like to have an optimum selection. And by including your pollution performance curves into your insulator specification, you would find that you can optimize your insulator selection. And so specify the pollution performance curves and specify it for specific values you would like to have the baseline tests done. And as we showed in the presentation today, it is really a very good option. So at the end of the day, folks, for optimum insulator selection, start using the latest IEC technical specification 60815. It's really worthwhile. And the note here is that at the end of the day, you must take note that it's definitely not taking into consideration aging and failure modes. So this is for pollution performance only. Thank you. It was an honor and great spending some time with you. And remember, the person in the mirror who observes and measures with calibrated instruments knows. He who measures knows. All of the best and enjoy the rest of the conference. Goodbye from the Knysna Forest.